Hello, my name is Meagan Goodridge, and I would like to thank you for joining me today as I present my IDEA grant-funded project. The title of my project is Identifying Mycoplasma Pneumoniae Protective Antigens Using Proteomic Approaches. This project was focused on the bacteria Mycoplasma pneumoniae, which causes what is frequently known as walking pneumonia. Mycoplasma pneumonia's ability to cause disease is increasingly becoming worrisome as antibiotic-resistant strains become more prevalent. It has been noted in past attempts to develop a Mycoplasma pneumonia vaccine that priming a host with Mycoplasma proteins can exacerbate disease. However, in one study, it was noted that a subgroup of treated proteins were shown to provide some protection against Mycoplasma pneumonia infection in mouse models. The objective of this study was to characterize the potential protective nature of Mycoplasma pneumoniae delipidated LAMP proteins and to identify protective antigens that could potentially be used in a vaccine candidate. We attempted to identify protective proteins by separating them with native phage gel electrophoresis, which were then meant to be fractionated and tested in mice. However, these delipidated LAMP proteins did not separate in the native phage gel, and we questioned whether or not we needed the native phage to keep the proteins in their native conformation. This led us to the second part of the study, which was determining the differences in host immune response to the delipidated LAMP proteins in their native conformation and after being denatured. After vaccinating mice with either the native or the denatured proteins and then challenging them with Mycoplasma pneumonia, it was determined that the mice that had received the proteins in their native conformation were more protected than those that had received the denatured proteins. Finally, we vaccinated mice with either a sham vaccine or with the Mycoplasma pneumoniae F-type ATPase lipoprotein, which retains its native conformation, and challenged them with the Mycoplasma pneumonia. We determined that vaccination with the ATPF offered the mice protection from the bacterium. This project may lead to future understandings of how to separate and isolate Mycoplasma proteins for their use in mouse models, the importance of retaining their native structures for inducing a protective immune response, and the characterization of the type of host immune response that is necessary to provide protection. Overall, this project has the potential to contribute to future attempts to develop a vaccine against Mycoplasma pneumoniae by providing insights into possible vaccine target antigens. I would like to thank the Sapanic and Geary Laboratories for their support and guidance on this project, as well as the Office of Undergraduate Research for funding this research. Thank you for watching.